Alright, so in this video we're going to talk about the forward and backward, and I guess you can also do both type of stepwise regression procedures, and using R to do that for you. Okay, so in the previous video, we talked about this data set where we had someone's insurance charges, their age, their BMI, children, female, so 1 for female, 0 for male, and 1 for smoker, 0 for non-smoker. So we had this data, and what we were trying to do is figure out which of these predictors are important for the modeling insurance charges. Okay, and remember, you always check your assumptions before you do any type of model selection procedure. So you want to make sure that your error or your residuals are, have a nice normal distribution, that they're randomly scattered around 0. If you need to do any transformations or need to address major problems with those residual terms or major problems with your model assumptions, you need to do that before you run any type of model selection procedure. Okay, so previously I showed, in the previous video, I showed how to use this OLS step all, which basically will run all possible models, right? And when you have only 5 predictor variables, that wasn't a huge deal. But when you have more and more predictor variables, it becomes harder and harder, even for a computer, to run all possible models. So that's where these stepwise procedures come into play. All right. So first, let's go ahead and run the forward stepwise procedure. So let me write forward stepwise regression. And the way you would do this in R is you would type in OLS underscore and step underscore and then forward. Okay, now you're starting to see some choices. You can use, I think that this one automatically uses P, but yeah, so you want to specify one of these two, I think. So either you want to use the AIC or P values. We're going to use P values. So basically, we're going to let predictors enter the model based off of their P value. Okay, so go ahead and give it the model, right, which we previously defined here. Okay, and then give it the P value to enter. All right. So to enter the model, I want it to have a p-value of at least 0.05, okay? And then let's go ahead and run this. So press Control, Enter. And of course, I didn't run anything else before it. So yeah, remember, you have to run, let's run all this other stuff. Control, Enter, there we go. And Control, Enter, there we go. Okay, you have to make sure, yeah, you have to run everything. Otherwise, of course, I didn't see anything because everything's already cleared out. So, yeah, here we go. So this is the selection summary, and so basically the first variable it chose was smoker. Okay, and the way the forward selection model or stepwise procedure works is it starts with a model with nothing. And then it says, okay, which of these regressors is the most significant, smallest p-value? And then it said, oh, smoker is going to have the smallest p-value. If I enter smoker into the model, that's going to be the best. Then it says, okay, which one is the next variable I'm going to enter them into the model that will have the smallest p-value? It said age. Okay, then BMI is going to have the smallest p-value. And then let's go ahead and add in children. The number of children has the smallest p-value. And then it stopped. Okay, and why did it stop? Because it stopped because in order for another variable, so I guess if it was female must have entered the model with it must have at least a 0.05 p-value, and it didn't have that. It didn't meet that criteria. So that's why it didn't get to enter the model. Okay, so what model did this forward selection procedure select? The model with smoker, age, BMI, and children, which is exactly the same as we found when we were examining all possible models. Okay, so now to do the backward stepwise regression. Okay, we'll run OLS underscore step underscore backward, and we're going to have .p. Okay, we're going to give it model. Then we're going to give it the PREM, and so that's our p-value for them to remain in the model. Okay, so to remain in the model, I'm going to use 0.1. All right, let's run that and let's look at what it found. Okay, and the way backwards elimination works is we start with a model with all of my predictors, and I'm looking for which of these leads to a insignificant change in how well the model is performing. Okay, so it looks like it decided to go ahead and remove female. So that's the only variable it decided to remove. Then everyone else it was important for it to remain in the model. Okay, so it didn't move on from that one step. So this was a very quick. In terms of computation, the backwards was the most computationally efficient for this particular model, right? Because it only included this one. Just go ahead and remove female, and then keep everything else, right? All right. Lastly, there's a bidirectional stepwise procedure. So I'm just going to call this stepwise regression, right? And the way this works is OLS step, and then it's called both, and then we'll use p-values, okay, to enter and exit. And the way this works, it's the same as forward and backwards. It's combining both of those. So where at each step we'll decide whether or not we want to include more variables or eliminate variables. Okay, so it considers both going forward and backwards. All right, and then you want to go ahead and give it the criteria for entering and remaining in the model. So you can type in p enter equals 0.05 and p remain equals 0.1, and then run that. And what you're seeing is it looks like we have only decided to add, okay, but we never needed to remove any of these variables. So looks like our results, once again, are exactly the same. That smoker, age, BMI, and children are important in this model, and female, whether or not you're a male and female, appears to be a predictor that you could exclude from this model.